Hello, Algebra 1 students. Mr. Ford here. This is part 2 of the answer guide for 4.3.1, which is a big assignment. And like I said in the last video, I want to, first of all, flip back to problem 4.100, which I would not recommend that you do using paper and pencil. That would be a thing I don't think you should do. A graphing calculator is an excellent thing. What you want to do on a graphing calculator, if you have one, is go ahead and type this into the y1 menu, negative x squared plus x plus 2, and you will be able to see the graph and the table from there if you remember those commands. Pushing the graph button, I'm going to hold up this to the webcam like you can see it, but pushing the graph button and then pushing the second and the graph button, look at the table. Although today what we're going to look at is Desmos, which is probably a better tool for the job. I'm going to move this to the bottom, and you can be able to see, maybe not, order, move to bottom. Okay, we'll try it one more time. Oh, I've got it moved. Okay. Oh, maybe not. Okay. Oh, I see what's happened here. Perfect. Okay, order, move to bottom. In my head, that was a lot more fluent. Okay. What you want to do is open up a Desmos tab on your Chromebook or whatever browser, maybe the thing you're using to watch this video right now. And what you can do is go over here and you can just type the equation in, y equals negative x. For squared, you're going to want to use Shift 6 to bring it up there. Shift 6 is the arrow key that looks like that. Plus x plus 2. Like that. And you will be able to make the wonderful graph happen right there. There is the graph. Now, if you wanted to see a table of this, you can click plus and you can click table, and you can just go ahead and, let's see, there's a way to do this, and I'm not entirely sure I know what it is. Actually, honestly, what you should do is just click on the points to tell what the thing is. For now, that'll work pretty nicely. So I'm going to make a table with this graph here. I'm going to see if I can move this off to the side. And I'm going to see if I can bring my, my tablet up to the top layer here. Tablet, order, move to top. Perfect. See, it'd be cool if I can get both these things on the same monitor at the same time. That'd be cool. Okay, so what you want to do is at this point, you could probably make a pretty darn good sketch of this. The instructions of the problem do say to label the x-intercepts, so we're going to do that. You can go ahead and just click on them in Desmos. They're negative 1, 0, and 2, 0. I'll slide to the side there a little bit. So I'm going to go ahead and put points at negative 1, 0, and 2, 0. I'm going to go ahead and label those, 2, 0, and that point right there is negative 1, 0. The y-intercept and the vertex are probably good points to know also, just to be aware of. 0, 2, 1, 2, put a point right there. And then the top point appears to be 0.5, 2.25. I'm just going to put a point kind of right next to it. You can go ahead and sketch the parabola from there. It'll look kind of like that. As far as the table goes, we'll just go ahead and make a quick XY table here. You can kind of choose where to start on your graph, but I'm just going to click on some points there. I think it's probably important to know the point negative 2, negative 4. It's not going to show up on there, but I'm going to put it down. That'll be the first one. Negative 2, negative 4. We already know negative 1, 0. We also know 0, 2. 1 looks like it's at 2. 1, 2 is on this. And 2 is at 0. And you know what the heck, why not get 3 in there too? 3, 4. It's 3, 4, yeah. So there you go. Desmos is the tool for the job in this case. Okay, I'm going to make this bigger so we can do our work on the tablet. That's the key for the rest of this. Let me bring myself up to the front too. Order, top. Okay, cool. I haven't done that. Haven't been that advanced with my tablet work in a while. So okay, let's talk about where we left off at the end of the first video, which is 40104 C and D. Here we got scientific notation, which nobody is a fan of, but it's actually really easy. 3 times 4 gives you 12. And then 10 to the third times 10 to the fifth is 10 to the eighth. Honestly, that's all I would do for this problem. I wouldn't try anything else. I wouldn't do... I guess some people will say it's not scientific notation unless it's 1.2 times 10 to the ninth, just moving the decimal point one more spot there, but it doesn't matter that much. Over here on this side, question D. Again, you want to do 4 divided by 5 first. 4 divided by 5 is going to be 0.8, which you could ask on a calculator if you didn't know that. 0.4 divided by 5 is 0.8. And then you have 2 minus negative 2. This is going to be 10 to the 4th power because 2 minus negative 2 gives you 4. When you're dividing exponents like this, you want to subtract them like that. Moving on to the next question. Here we have f and g, two separate functions. We're going to plug in -5, and we're going to plug in 64, and plug numbers into this. This first problem is going to be 3 minus the absolute value of -5, which is 3 plus 5, which is 8. For g of 64, you are going to need the third root of 64 plus 5. The third root of 64 is going to be, I got to think about this one, it's going to be 4. Because 4 times 4 times 4 is 64. That's the thinking going on in that problem. And then 4 plus 5, of course, is just 9 for the final answer. F of 0, this is going to be 3 minus the absolute value of 0, which is just 3 minus 0, which is 3. F of 2 is going to be 3 minus the absolute value of 2, which is the same as just 3 minus 2, so that's just 1. G of -8 is going to be the cube root of -8 plus 5. The cube root of -8 is -2, because -2 times -2 times -2 is -8, and then that makes it 3, the final answer. And then g of 0, this is the cube root of 0 plus 5. And the cube root of 0 is 0. So this is just going to be 5, like that. Trust your instincts on that one. For 106, decide if it's true or false and justify. Is x plus 3 times x minus 1 equal to x minus 1 times 3 plus x? It is true. It's true for two reasons. Number one, order doesn't matter. When you're multiplying. That is the word multiplying there. My pen seems to be kind of shorting out on me. The order doesn't matter when you're multiplying. So the only thing different here is they change the order around of these two. So it does not matter what order. Also, inside of x plus 3 became 3 plus x. But it also doesn't matter if you're adding. They're the same. What you could do, if you wanted to be advanced, you could actually multiply these out using a generic rectangle, or just by doing it, because you're that smart at this point. You get x squared plus 2x minus 3 for the first one. And over here you get x squared plus brain farting plus 3x minus x minus 3. You get the same thing. You get the same parts. There, you get the same thing for both of them. Next question. Speaking of which, in 4107, find the following products by drawing and labeling a generic rectangle or by using the distributive property. Again, it's up to you how you want to do this. You don't need to draw the generic rectangle too much, but you know, it's probably a good thing if you're still starting off or still feeling like you don't have a good handle on this to draw it all the way out. X times x, x squared. X times 4, 4x. X times 5 is 5x, and 5 times 4 is 20. And you just add it all together. You get x squared plus 9x plus 20, and that is all she wrote about that problem. The 9x comes from the 4 plus the 5, by the way. Over here, this is even easier. Just going to use the distributive property. 2y times y, 2y times 3. That's 2y squared plus 6y. And that's all there is to this assignment, my friends. Hey, you made it this far. You guys are great and awesome. You're going to do just fine on the upcoming chapter whatever test, chapter 4 test. So I'll see you guys on Wednesday, and I'll see you in the next video.